Mexico City all my elementary education and either up to high school. And then in high school I wanted to do chemistry, and this after I decided that I wanted to do that, and because I found it extremely interesting. But then my teacher, I was, for some reason, I was interested in the what were nuclear phenomena. And then my teacher told me that I had to go to physics if I want to become a nuclear physicist rather than a chemist. So then I decided I have to go to physics. And that was back in the 60s. So being a nuclear physicist was very prestigious at that time, apparently, so that's why I am. But I always got interested in chemistry. For a while I considered to really take courses in both schools, which is possible in Mexico to take at the same time physics and chemistry, like majors. But I found that was too much, so I gave up a little bit of the chemistry. And then I went for my my bachelor's degree and then my master's in Mexico. And then I go on doing the PhD in Mexico, but at that time I finished up taking courses in Mexico, but we did not have good people to really be thesis advisors, okay, to really get you into something novel. So I decided that I should go to England to get somebody to give me a thesis and work in my thesis. And then I went to England because I was advised by Dr. Nicolas Cabrera, who was, in my opinion, one of the greatest scientists in the Spanish-speaking community. At that time, he was a very famous man. He went to Mexico because his family came from Spain, and then during the Spanish War, many people went to Mexico, so I think his mother was living in Mexico, so he used to go to the university and get involved in teaching, even though he was very famous by the Frank Burton and Cabrera theory of crystal growth. And he told me that surfaces were the way to go. And he called some friends in England, and then I went to first to Cambridge and to Warwick to work in my PhD thesis, which I finally succeeded in finishing some experiments that I took back to Mexico. And I really got involved in catalysis after 6 years of working in Mexico in electron microscopy. I went to Oxford for a sabbatical, and then I became interested in small particles because I was trying to study nucleation phenomena, not really catalysis. I was not involved in catalysis at all. I didn't know anything about catalysis. But then when I came back to Mexico with all these techniques I had developed to study small particles, my friends in the Petroleum Institute in Mexico, by chance they invited me to give a seminar. And then I realized there that in catalysis there were exactly the same problems that I was working at in the other area. So I really didn't know that small particles were so important to catalysis until I got in contact with the petroleum people. And then I got involved in catalysis that way, which I found was very, very fruitful to me, because I had the techniques, I had the problem. I was a solution looking for the problem, okay, and they were the problem, okay. So it was very nice, and then I guess that was really the key point, and that's what I then try to tell my students, that they always have to connect with the right problem. That's the right thing to do. And over the years, I've been learning, going back to my old love of learning chemistry, which I always wanted to do because I have to, even to understand the language of my colleagues in the catalysis area, I have to really learn more about catalysis. And that's the way, even though I think, I look at the problems like a physicist, because I guess I cannot change that. The interaction with chemistry is one of my, what I consider a success in my career, with the interdisciplinary approach in this thing.
What is it that you look for in deciding on a research area?
Okay, what are the objectives? What I look for normally? Well, you know, I want to have fun when I do research. If I have to do, research which is not fun, I don't like it really. So I always look for areas in which the problems are fun, not necessarily extremely hot problems or very prestigious problems, but something that gives you, interest in thinking and something that you really learn something about it. Not just not. I don't like routine things. So, but I also don't like get into fashions very easily, okay? Because fashions are very dangerous, especially if you're involving young people working with you in fashions. That might destroy their whole careers, which is. In fact, I learned that working in my PhD thesis. I worked in something that was almost already explored, but I found new things. And my philosophy is you always learn new things when you attack the problem correctly. So I never want to do, but I have to have fun. I mean that it has to be something new, something interesting, and there are many people. I just discussed that with some of my colleagues last week. There are people who always picked up the problem, okay, the biggest problem, and they want to solve the biggest problem. And I don't know any good example of anybody who has succeeded in that, okay. Whereas if you try to solve fun problems, you end up probably having something very important for other people. That's more or less what I think is my philosophy. And also, the other philosophy in Mexico is that we have a lot of limitations. So we cannot tackle all the research we want. We have to also be adapted to the conditions we have there, like equipment and budget is always important. We cannot decide on an experiment without thinking on the budget first. And I think this has done a lot of good to Mexico because at the end makes the people thinking more in the experiments. And we do not have these biggest physicists involved in huge projects that take a lot of money and a lot of time, and that because we don't just have enough money, but then the tendency is to work in problems in which you can have some instrumentation in your own laboratory, which is rather than big facilities or big things. And also I like to cooperate with people. I think it's always fun to cooperate with people in different aspects and then learn about other people in the same problem. That's what I found is very exciting, that to interchange of ideas in this point.
But yet you were able to get the state-of-the-art microscope equipment in Mexico. Was this a conscious effort, or?
I was that took me a lot of effort. Well, first because I was appointed the director of a very prestigious institute, and that helped me a lot. So that opened me many doors. And this particular project, I have to really go up to the top in Mexico to get it. Okay. In fact, I spoke to the president of Mexico about it, this project, and you see, I took advantage of one of the things that was probably a little bit of a lie, if you wish, that the president of Mexico used to read the Time and the Newsweek always. This is the president de la Madrid, and he read about the superconductors. Okay, and he was very excited. He learned that somebody in my laboratory had developed this levitation effect, which is very, and he wanted to know more about it. And then when we discussed and showed him, we said that we could do a lot of research in that area with a microscope of high resolution, which was not really, as I said, was a little bit of a lie, because even though we wanted to do some superconductivity, we really were more involved in catalysis and small particles. So we got the microscope that way. It was a special budget that was given by the president. So we got the microscope, and then the Institute of Physics has enough infrastructure to really sustain the microscope working, and also we got an extremely good bunch of people. So young people working around the microscope. So that produced the perfect setting for that such a machine. But there are not many, facilities of that price or that cost in Mexico, okay, which is, if you say sometimes you have to play a little bit of games, and of course I got some images of superconductors, which are very easy to get, and I sent it to the president. He was very happy about it.
Well, how did you get into some of the administrative aspects of research?
Well, my experience is that, unfortunately, this is something that goes with the research. You cannot really avoid to do administration, okay? It's not a dirty thing, I think it's a necessary thing. And if the scientists do not get into administration, then the bureaucrats will do it. And then we have a problem because they don't understand what is going on. So I think some of the scientists have to devote his time to do some administration, even though it might be a waste, for a personal waste if you wish, but it's an important social function that it has to be covered. If scientists do not do any administration, then we will end up having a very different scientific establishment altogether. And in Mexico, that's even more important because the scientists have a lot of impact with the society. Okay, it's a very well respected profession, not very well paid, but very well respected. Okay, so if you have non-scientists doing administration, then it will be a very bad image for the understanding of things. And also when people talk me about their problems, now being a director, I understand what they're talking about, because I went through the same things. And I went through the same, desperation of getting the equipment on time, the eagerness to go to conferences, the interest in, inviting some people to discuss results. So those things are very difficult to understand for the politicians or the non-administrators. It's not because they haven't lived through that thing. And also I think I see my role now is that in Mexico now is being built a tradition in catalysis now. Fortunately, despite of all the political problems with the oil companies, or the oil company, because there is only one, now a tradition in catalysis is being built. And I think we have at least 2 generations now of scientists now working in catalysis. So I can see in Mexico, for the future, a very bright group of people working in these kind of areas, which is going to be very important for a country which needs desperately the catalysis in many respects. It's now Mexico is changing totally towards being a modern country. Because the goal is to eventually, I think, become integrated to the North American continent like a society. So that is producing that science has to play a role in that modernization. That a country cannot be modern without science, and that has been clearly established. And now people is developing science. So our main goal now is to train new people and to produce more scientists to really achieve that goal. Because I guess the rate limit and step in this thing is in the people, that you take a lot of time in forming the people, okay, educating the people.
Well, you seem to have been able to stay active in technical areas, even though you have devoted time to administrative work. How can you do that?
Well, that's a difficult situation. I devote the half of my time to science, okay? So I try to be very efficient in the morning, just taking all the problems and solving the problems, and then I don't do anything like that. In the afternoons I go to science, and in the evenings to my family, which is very important. And I have always a tight schedule, if you wish. I'm always under pressure, but this way works very well because like doing science keep me alive and understanding the problems, because if you don't do science and just go to administration, at the end you decay to the bureaucratic state eventually. And I guess going to the lab gives me, and in fact, even though now working in the lab, and going to the library, like I can see then the problems that the other people are facing because I'm doing that. And you know, the big mistake I made the first 2 years of my administration was to really get involved too much into administration, and that was very bad because I think fortunately I changed that. So, and after I stay with my family, then I take some time in the late evening to work a little bit in writing papers and so on. And, you know, and but yeah, fortunately or unfortunately, I had a little accident at the beginning of this year playing baseball in the weekend. I broke my Achilles tendon, so I had to go to surgery and I had to stay in bed almost 1 month and a half, and that gave me a lot of time to write papers and so on. It was very good time at the end.
And are you going to get any of your family into science?
Well, you know, that's one of the problems that I guess my 2 children want to get into art. Okay?
Oh.
I think that's one of the things that even though I am very close to them, they don't really understand because they see you in the desk, you know, writing things and scrapping paper, and I guess it's very difficult for the children to understand the sciences. So they're happy about art. At least at this moment, they don't want to go into science, and I don't want to pressure that. I just waiting that maybe eventually they will go into science, or maybe my grandchildren, not really my children, go into science. Also because I always interested in art, and I guess I take a lot of time going to the theater and going to the movies. I like very much movies. I like history, and I guess also the children get the message through that. Okay, that's not. You know, it's not that easy. And also I find electron microscopy is. You know, sometimes you have pictures who are really artistic, so it's a kind of a joy to have this kind of pictures. Okay, like I'm not trying to collect my pictures I've been taking all my life to end up having a book of just pictures that might be, you know, beautiful pictures that are just from the nature. It's this kind of thing.
Who did you work with in England?
Okay, I worked initially with Alan Bassett, who developed originally a technique to look at steps on surfaces, what's called gold decoration. And then when I came back for my sabbatical, I worked directly with Peter Hirsch, who was a you know, extremely important person in electron microscopy. And that gave me, probably what he gave me was a lot of confidence, because I was working with the best in electron microscopy, so I was sure I could do the best in one time. And I think that's one opportunity that the young people should have, you know, to really go to the best places to interchange experiences. That in my case worked very nicely. In the case of my PhD thesis, I got directed into surfaces, and always have this advice from Cabrera that. You know, Cabrera is probably the most influential man in my life, Nicolas Cabrera. He was the chairman in the University of Virginia, and he developed many theories about nucleation, about shape faceting of crystals. And I always kept contact with him, and surface melting, and I guess he always gave me new ideas, and I would say that's the man that I respected the most. In fact, I named my son after him. It was Nicolas, his name, so he was Nicolas Cabrera, because I think he was really my real, even though he was not my advisor in any time. And then, because he took a job in Spain finally. When Franco died, he was recalled to Spain like a professor, and he started the University of Madrid, the physics in the University of Madrid. And so I saw him in Spain several times, and I always got, you know, very nice information about him, and I like him very much. You know, it's I consider him the most influential scientist in my life, even though, and also he was somewhat involved to catalysis through surfaces. Okay, he sort of mentioned always that it was very important to study the surfaces and the surface of crystals, of course. with the idea of going into applications in one sense.
How much interaction is there between university, like you're in, and industry, PMEX?
Well, let me tell you the situation now. Since Mexico wants to build up a competitive industry, now what they did is they opened the borders to any company who wants to get into Mexico, or any company can import technology from whatever. Before that, there was protection, okay? And in a protective society, the science do not develops. But once they open the borders, then the companies that want to survive, they have to have some technology. Okay? So we have literally thousands of requests from companies of all kinds looking into problems which are related to either catalysis or material science of small particles, if you will. And all those companies are now looking for ways to get involved into with the universities. And also PEMEX is with a lot of pressure from the public to clean up the gasolines, to produce better products and so on. So they are very worried because they do not have all the technical possibilities so they are getting closer to the universities. And now our biggest problem is that we have no enough people to really respond to the demand. Okay? So we are now in the situation that people do not finish the PhD because they got a job before finishing. So we have to keep them kind of secret so we don't have them until they finish, otherwise they go away before. And now in Mexico, that's probably my view, is that we have to really produce more people to deal with the change. Okay, so because it's a tremendous change and still 10 years ago, it was considered a dirty thing to interact with the industry. Okay? It was a pure academic life. Now it is considered a normal thing, which is, and we cannot cope with the demand. This is what I would say.
Yeah, how would you compare education in England and Mexico at the time you were a graduate student?
No, I would say that, you see, the theoretical education was about the same. In fact, sometimes I even knew more about the theory that my England fellows, okay, my co-workers or my companions or colleagues. But the experimental part was very weak in Mexico and very strong in England. So that was the main difference. So I would say for a theoretician was about the same, for an experimentalist there was a big difference. Okay? And also the technical support of the laboratory was much better in it. And that's what I try now to do, is to provide an atmosphere with a lot of technical support so people can really don't have to worry about doing things that are taken away from the research as much as possible. And that's also one thing that I envy from the United States, that the atmosphere of the universities is very nice. And although we have an advantage, we have still groups which are formed by permanent people. Okay, like people is not supposed to work individually, but in a group. Okay, and that's one of the advantages that we have in Mexico, that we can work 3 or 4 people in the same problem. So we put more brains into the problem and that's probably one thing that we might end up being very, very important in the development of science in Mexico. Because the problem with Mexico is that we do not have scientific tradition, and the scientific tradition was always, has to be built. We had probably the most well-known scientist of the last century was a chemist, Dr. Andrés del Río. He discovered a new element back in 1840, okay, which I think at that time was the biggest discovery in chemistry, and he used the name erythronium for that element. And but he was not really sure that it was a new element. And then von Humboldt came to Mexico. He was traveling around America, and he gave the samples to von Humboldt to prove that that was a new element. And then von Humboldt take the things back to Germany and took a long time to, in fact he forgot about it. And then a group in Scandinavia rediscovered the element that called it the vanadium. Okay? And then later on, von Humboldt took the samples from Andrés del Rio and checked that it was really all the erythronium was there. And he never got the credit. In some of the old books in chemistry, you see this, the vanadium called erythronium. In fact, in Mexico, it's called erythronium. We don't call it vanadium, okay, because of the Andrés del Rio. But that tells you how the science was, that we did not have the atmosphere to produce science. That was, so we depended too much on the external referees, more than that. And that was the story of the science through the century, I guess. The only important scientists start to come out probably in the 60s. So which is too late in the development of the country. We always have, one or two people good, but not. The only famous people, Mexican, were people working in the United States, not in Mexico. That's probably the basic thing.
Well, one of the big things that Liebig became famous for in Germany was his teaching school. You have somewhat a similar setup for Mexico now with developing the science. That seems to be important to you. Is that a...
Absolutely. That's was my main goal. I think that would be my main achievement if I can really finish that, to live at a school in Mexico of scientific tradition. And the difference is that, you see, I was told by my boss when I got into the Institute of Physics, before getting my PhD, we got jobs because in fact, I was sort of permanent employee before getting a PhD, which is very unusual, but that was my situation. And he told me, look into the literature, look at the classic work in the field, and then see what left from that particular problem, and then try to cover the holes, okay? And that's the way you do science. Okay, I found that way you end up doing very relevant things. You're always behind the rest of the world. Now I think through my career I have changed and destroyed that style, and now in Mexico I told my students, go to the very border of the science and do something new, something original, and try to do a classical work, not try to just follow the classical work. So I see in Mexico many new aggressive young people which are really looking into the way of really produce original science and trying to do not super big problems, but original problems. That's probably the school is now being for more aggressive, a little bit more aggressive. That sometimes aggression is very low in Mexico, and people do not is not as ambitious as it should be in scientific goals.
What is it you look for in a student?
But first, I would like them not to feel that. To be interested in science. That's one thing. Okay. Secondly, he has to be, in my opinion, aggressive enough to know that he will have enough capability to produce original science, which in Mexico it's very important, because if you talk to the people in the streets, they will tell you that the science is something that is made in the north by the white people, not by the Mexicans, okay? And to break that attitude and to say that we can be a technological state, which is changing that in Mexico, by the way, because that's the thing is changing so rapidly that I can see my country changing that much. So I want a student to really be in a position of producing original science in a very short period of time, and then you'll really be creative. That's the more important thing. And independent, that's one thing that's because in Mexico, let me just tell you a little bit of a story which is not in psychology. In one of the tests in psychology they do for the children, there's one question that says, if your mother sends you to buy some bread and you don't find the kind of bread that your mother asked for, what do you do, okay? And in the United States, the proper answer is, say, well, I get another type of bread which is similar. In Mexico, the proper answer is to say, I come back to my mother and ask what to do, okay? And that's the intelligent attitude, so according to the psychologists, because socially, there is a strongly dependence upon the leader, okay? And that's the same in science. Science, the leader, you know, it's plays a very important role. So I wanted to change that, I wanted to be independent and to take independent roles and to create their own problem, their own line. I don't want to build up a pyramid like in Germany, okay? Which is, I don't think is a good idea, but to build different independent lines, which I think is, and I've been achieved because, you know, we have bright people, Fuentes, Sergio Fuentes, Gabriela Diaz, Victor Castaño. There are new people which are coming, Dominguez, which are coming with new ideas in different directions. They all come from this same group that was originally stated through electron microscopy.
Have you picked out another area in addition to microscopy to build on now?
Well, let's say I really, later on I became interested in quasicrystals because I think the icosahedral symmetry or it's something I always have been interested in my life, even in the clusters. So since these are solids with icosahedral symmetry, I got involved also in those solids. And also there are very beautiful physics which is being done there. And I enjoy it really very much. So I'm kind of, my two main works are small particles and quasicrystals are now my two main topics of work now.
How do you get a person to branch out and start on their own?
Well, first I give them the facilities to do it. And I told them, you know, I will enforce you to do that. In fact, you will have all my support to do that. And then, in fact, I encourage him to do that. Okay, for instance, I stopped publishing with him, and if he doesn't get into his own publications, he will get in trouble eventually. So I don't want them, because I don't need more publications really. Okay, my curriculum will not change too much with a few other publications. So he has to get some more publications at his own, and I tell him, don't put my name in it, and don't even. You just show me the paper, I will gladly correct it, but I will not write it or cooperate with that. And I think that's a good moment when they really write their own papers and write their own ideas, and that's the moment in which this is important. First, you have to realize that in Mexico the language might be a problem for some of the young people to write in English. They're not used to write in English, so they have to learn on that. And sometimes the referees are not very kind with the Mexican because the English is terrible, so we have to do an extra effort. Besides of the scientific errors, we might have a lot of mistakes with the English.
Well, a lot of countries are coming around to English, at least in the education.
Absolutely.
Is this being encouraged in science now in Mexico?
Absolutely, absolutely. I guess people are able to read and even to understand, even to write in English. But the problem is how to write proper English. Yeah. That's the point. Okay, it's not just writing, because they write in Spanish with using English words, and that sounds awful. Okay, you know, so they have to really learn, and we're trying to. You see, Mexico. My view is that Mexico, in a few years, probably no more than 10 years, is going to become a single country with the United States and Canada. As the way it's happening is so fast that you know, I see the change, and you know, all the politicians in Mexico are working in that direction. They're trying to change the history and say, well, after all, our neighbors are not that bad, so we should be, you know, more friendly. And seems to me that the trend is to produce first economic blocks, and later on, you know, the boundaries become more. So the language should be very important. I think most of the Mexicans realize that they have to learn to speak as possible in English. Okay. I try to do that with my children. They speak much better English than I do, and by far. They went to school and they got very early into the language, and it's one thing that I think I did it right, because they are well suited in both languages.
Is part of your task now to get science down into the lower levels of school, or have you gotten involved in that?
I have got involved, but it's a very difficult thing. The problem in Mexico is that the salaries are not very good for the scientists. So when the young people look at the career like a scientist, they see a salary which is not, doesn't look very decent. Although it's not that bad, really, but it doesn't look that. So it seems to me that now science is about to become it's a way that there is a lot of not only interest for a child, but they have to be they can make a respectable career out of science. So not really. I guess science now should be more looked at like a profession like any other, okay? Because we need massive numbers of scientists. So it has to be a profession for decent professor, like a profession like being a lawyer or whatever. And I think that's what is keeping many people in Mexico in getting involved in that. Also, half of the population in Mexico is under 18 years. So if you get involved in teaching the young people, it will take forever because there's so many people. I don't want really to spend most of my life doing that.
Do you have anything we've missed?
No, I just say that maybe the last thing I would like to say is that I just want to say that the catalysis I found is one of the most fascinating areas in science, because it has this interdisciplinary component, and because it's so. One thing is that you can see that what you are doing has some impact in the industrial area, even in the short run. Okay, that's very important. That's one thing that frustrates me very much from physics. That what you do doesn't seem to have any impact in anything. Okay, so that at the end becomes like a mental exercise, but not some. So that's one of the things I really like about catalysis. Okay.
Wow, this Pat, keep it off that way.